Yo, 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 yo! Alright, this is the last of Module 9, talking about congruent figures. So basically what we're doing is we're making connections between transformations and congruent shapes. So the first thing we need to talk about is, what does the word congruent mean? Some of you might know from past, from 6th or 7th grade, and we might have forgotten. Congruent means something that is the same shape and the same size. So if I have a square here and I have this square right here, these are both squares. They are the exact same shape. However, these are not the same size, so therefore these are not congruent. Okay? But with all the transformations that we've learned so far, is if I take the same exact shape, such as this little triangle here. Actually, here, let's do a different one here. Let's say I have this triangle right here. And if I take this triangle, and let's say I translate it in some way where I move it over, it's the same exact size and the same exact shape still. Okay, it's just that we moved it. Or let's say I rotate it. Well, if this became this, they are still congruent. They are the same size and the same shape. They're just oriented and facing a different direction, but they're still the same size and shape. So therefore, this triangle and this triangle are still congruent. Okay. Now, really, what we're doing today is we're just combining multiple transformations. Okay. So each transfer we're going to do. This one right here, we're going to do 5 different ones. Okay, each one is done to the one afterwards, right before it. So here we go. I have my initial triangle, and I'm going to start by reflecting this across the x-axis. So we're just going to take this one step at a time by performing our transformations. So, and we label it accordingly. So after I reflect this, because this is part A, I'm going to label it as triangle A. So when I take this and I reflect it across the x-axis, here's my x-axis right here. Okay, so if this is my x-axis, I'm going to count each point. That's 1, 2 away from the x-axis, so 1, 2. Okay, that's 1, 2 from here, so it means it's going to be 1, 2 from here. And then this one is just right alongside. So here's my reflection across the x-axis, and we're going to call this triangle A. Okay, now for triangle B, I'm going to take this A, and then I'm going to perform B here. Well, this is telling me algebraically to take whatever the x values are and then move it left 3, because x minus 3 means move this left 3. And don't do anything with the y, so we're not going up and down. So I'm going to take every point from A and go 1, 2, 3, there's my new one. 1, 2, 3, there's my new one, and then 1, 2, 3, there's the new points. So this would be triangle B, because I went from here to here when I reflected, and then I slid it over 3 for this new translation. Now it's asking me to reflect across for C. I'm going to reflect it across the y-axis. Well, here's my y-axis. So if I reflect it, well, this is on the y-axis, so it just stays there. But then this is 1, 2 away, so now it's going to be 1, 2 away. And this is also 2 away, so it's still going to be 2 away. So here's my new triangle after I reflected it across the y-axis for C. Okay, now from C, we're going to do D here, which is telling me to leave my x the same and then go y plus 4, which means move everything up 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I just moved everything up 4, which is what y plus 4 means. There's triangle D. Finally, for my last one, it says rotate 90 degrees clockwise. That's 90 degrees clockwise. Well, the origin's going to always stay on the origin, so that's there. And then when I rotate it 90 degrees, it's going to look like this. And that was clockwise about the origin. And there's E, my final triangle. So this was where I started, and then I performed multiple transformations, and I ended up here at E. Now, I did all of these different things, 5 different things, but if I were to compare the size and shape of the final image, which is this blue one, to the original figure, this triangle and this triangle are the exact same size. If we look, this short side length, this is 1, 2 long. This side length is 2 long. This one's 2, and this one's 2. Okay, and then if I were to look at the slope from here to here, it goes up 2 over 2, up 2 over 2. So So they're the exact, all the lengths, all the side lengths are the exact same. It's the same shape of a triangle. It is congruent. Okay, so after doing all of that, I didn't change the size or the shape, and the triangle is still congruent. So now you're just going to have to combine multiple transformations. You also might have to identify what happened with one shape to get to the other shape. I don't know what shape this is, right? This is not a ordinary shape. This is some type of pentagon. It's got 5 sides, okay? But I want to figure out, how did I get from A to B? It's saying identify a sequence. That means it's going to be more than one of transformations that will transform figure A into figure B. That's how I know I go from A to B. So the first thing we look at is, are they facing the same direction? And we want to just get them to face the same direction. So the first thing I need to do is to get them to go the same direction. I think a rotation is not going to really work here, but if I reflect it across the y-axis, if I reflect it, and let's look at what this is going to look like when I do a reflection. Let's see, this is 1, 2, 3, so 1, 2, 3. So that's 4 away, so it's going to be right here. This one's straight down. If I reflect that image across the y-axis, it's going to look just like this. And if we notice, this is now facing the exact same direction. My tall point is in the top left here, just like this one is. So they're facing the same way. So that was by doing a reflection across the y-axis. So that was one transformation. Now I got to it's still not quite lined up to where B is, right? So now what I have to do is I got to move everything over to the left one. So now I just have to translate left one. You also could have written these rules algebraically. Say if I reflect across the y-axis, that means I'm really just changing my x value for points. If I'm doing a translation, left 1, that's x minus 1. So we have to figure out, how do we get from A to B? And you might have to draw it out if it's hard to visualize. So here's what I want you to try to do. We want to figure out, how do I get from B to C? So how do I get from here to here? And see how you do. See if you can identify a sequence of transformations to get from here to here. So pause it if you haven't done so already, and see if you can go from there. So they're not facing the same direction. This one, the top big, I'm just going to refer to this point. This point, or this indent triangle right here, is going up, and now it's going to the left. So I mean, they got to do some kind of rotation. And it looks like if I want to face in the same way, I got to rotate this way. So that's going to be a 90-degree. This is counterclockwise. Rotation. So I got to rotate 90 degrees counterclockwise. Now this is where it might be really nice to see where you end up. So if you physically do that rotation, you can see what your points are. Okay. Now by looking just at, if I were to focus on this point right here, this is a really good point of reference. Okay, if I were to look at this point right here, look at where I wanted to end up. That point is the same as this one right here. If I were to rotate this, this and this need to be in the same spot. So I need to get this point to the origin. So if I wrote this 90 degrees counterclockwise, it's going to look like this. Well, if I want to get this to the origin, I got to go up 2 over 1. So I got to go y plus 2, x plus 1, because I got to now translate it to slide it, because now it's facing the right direction. So I got to translate it up 2 and go over 1. Okay. So there's my last of my 2. I'm going to translate right 1 and then up 2. I'm going to put and up 2. And that will get me to C. Okay, so now last problem is right here. If point F is at negative 4, 4, so I'm just going to draw this on this graph. Negative 4, 4, oh, that's up here. Negative 4, 4, here's point F. And point G is at negative 1, 4. And they both are rotated 90 degrees counterclockwise and translated 6 down. What is the length of line segment FG after the rotation and the translation? So it's asking you, what is the length of this line from point F to point G? So if I were to draw a line here, This goes from 1, 2, 3. Well, if I were to rotate this 90 degrees counterclockwise, so again, counterclockwise is this way. So if I were to rotate it 90 degrees counterclockwise, it's going to end up here. Okay, it's going to end up at negative 4, 1. And then that's going to be right here. So if I rotate it 90 degrees counterclockwise, this is where I'm going to end up. There's G, there's F. And then I translated it 6 down. If I go 6 down, am I changing the size of this line? No. So it's asking, what is the length of line segment FG with the new points after the rotation and translation? Well, it's the same length as it was before because we never change the size and shape with these transformations. It always stays the same size. So this line segment is 1, 2, 3 long. So the new one is 3. We didn't change the size because these are congruent shapes. So don't let those kind of questions fool you. And we can add a ton. We can add 16 more transformations with translations and rotations and reflections and all the kinds of stuff. But the side length is always going to be 3 because that's just, they stay congruent. Okay, that's it. That's all I got for you guys today. So get the independent practice done. I want to see this completely done with your labels of A, B, C, D, E on your new rectangles. And then get it done. If you do not get the independent practice done, I will not give you credit for the notes because you should be able to do all of these at this point. All right, that's it. If you have any questions, let me know. Good to get us out.